So in this video, I'm going to be going over the divergence test, and all the divergence test says is that if you have a series that is a summation of the general an term, if you take the limit as n goes to infinity of that general an term and you see that it does not equal 0, then your series of ans diverges. And intuitively, all this means is that if you are still adding non-zero terms at the very end of the sequence, then you can't possibly converge. If you're adding sums infinitely, then you're getting an infinite sum, basically. It's important to remember that if you get a value of 0, then the divergence test is inconclusive and you'll have to do something else to find out whether your series converges or diverges. For each of the examples in this video, I encourage you to try to find the limits of the sequences yourselves so you can understand why they diverge. So let's take a look at these three examples. So for the first example, if we take the limit of n plus 1 over n plus 2, if you remember from your previous calculus courses that if you have a numerator that has the same degree as the denominator, you can just divide by the coefficients of the highest degree terms. In this case, it's just 1 and 1, so you get 1. And the second example is just a constant function of 2, so that if you take the limit, it's just going to be 2, and that diverges as well. And then for the final example, again, the highest degree term is 7 for both, so you get a value of 3 over 4 if you take the limit from n to infinity, and you will get divergence. So for this example, we're looking at ln of 2n squared plus 1 minus ln of n squared plus 1. If you recall, if you have two ln terms that are subtracting each other, you can use the log rule of division. So you can make the 2n squared plus 1 be the numerator and the n squared plus 1 the denominator. And then you can just take the limit of that as it goes to infinity. And since inside the ln you have equal power in the numerator and denominator, you can just take the coefficients of the two leading degrees and you'll get ln of 2, and ln of 2 is not going to be 0, so we get divergence here. So now we're going to look at an example with our boy arctan. So we have n times arctan n, and if you remember, arctan is bounded above by pi by 2, so as you go to infinity you're going to get pi by 2, and if you actually evaluate it, we just get infinity times pi by 2, and infinity times a constant is just going to be infinity, so we know that it's going to diverge because we're not getting 0. Now let's look at another example, the summation from 4 to infinity of arctan ln of n. Again, inside the arctan we have ln of n, and since n goes to infinity we're going to have ln of infinity, and we know that ln of infinity is just going to be infinity, and from the previous example we know that arctan at infinity is just going to be pi over 2. So this time we're going to get pi over 2 as our answer, and pi over 2 is not 0, so it's going to diverge. Now let's take a look at the example for the summation of 1 over the kth root of e. So we take the limit, I guess, as k goes to infinity of the kth root of e. We can represent the kth root of e as 1 over e to the 1 over k, as k goes to infinity. And if we do this, if k goes to, we can just plug in k as infinity, and we'll see that we actually get 1 over e to the 0, and anything to the 0 is just 1, so our final answer here becomes 1, and 1 is not 0, so it diverges. The final example I'm going to cover is a little bit more complicated, but it's not too bad still. So we have n times sine 1 over n, and we're going to use the divergence test to see if it diverges. So we're going to take the n at infinity, and we're going to change this into sine 1 over n over 1 over n, and we're going to take the limit as it goes to infinity. Now if we do that, we actually get 0 over 0. So what we're going to do is we're going to do the L'Hopital's rule and get the derivative of the numerator and the denominator and get the limit as that goes to as n goes to infinity. So if we do that, we'll get cos 1 over n over, or cos 1 over n times negative 1 n squared, and then we get negative 1 n over n squared on the denominator, and the negative 1 over n squares cancel out, so we just get cos 1 over n. And if we take n going to infinity of cos 1 over n, it's just going to be cos of 0, and cos of 0 is just 1, and 1 does not equal 0, so we get divergence. So the divergence test is a very important technique. If you can notice that something looks like it diverges, you can save a lot of time and headache by using it.